Transport layer. Transport layer is the layer 4 of the OSI reference model. The transport layer uses the services provided by the network layer, such as best path selection and logical addressing, to provide end-to-end communication between source and destination. End-to-end control provided by sliding windows, availability and sequencing numbers, and acknowledgement. The transport layer duties. Segmenting upper layer. Transport layer functionality is accomplished segment by segment. This means that different applications can send data segment on the first come first served basis. Such segments can be intended for the same destination or for many different destinations. In this figure 1, it shows a typical connection between a client and server. Client connection request acknowledgement and server request acknowledgement inform the server that both sides have agreed and a connection has been established. After the connection has been established, the data transfer begins. Windowing. Windowing is a method to control the amount of information transferred end-to-end. For example, in the most basic form of reliable connection-oriented data transfer, data packets must be delivered to the recipient in the same order in which they were transmitted. The protocol fails if any data packets are lost, damaged, duplicated, or received in a different order. The basic solution is to have a recipient acknowledge the receipt of each and every segment or data packet. But if the sender waits for an acknowledge after sending each segment, throughput is low. In this figure 2, it determines the amount of data that can be transmitted before stopping transmission and waiting for an acknowledgement from the destination. The larger the window size or in bytes for TCP, the greater the amount of data that the host can transmit before stopping. Acknowledgement. Positive acknowledgement with retransmission is one technique that guarantees reliable delivery of data streams. Positive acknowledgement requires a recipient to communicate with the source and sending back an acknowledgement message with it receives data. For example, in this figure, the figure 3, the sender keeps a record of each data packet it sends and waits for an acknowledgement before sending the next data packet. Then the sender also starts a timer when it sends a segment, and for the figure 4, retransmits a segment if the timer expires before an acknowledgement arrives. Flow control. Flow control ensures that segments delivered will be acknowledged, provide retransmission of any segments that are not acknowledged, and put segments back into their correct sequence at the destination. Also provide congestion avoidance and control. The transport protocols. The following are the transport protocols in figure 5. Transmission Control Protocol or TCP and User Datagram Protocol or UDP. See figure number 6. TCP provides reliable data transmission between hosts, and UDP transports data reliably between hosts. Both TCP and UDP use port numbers to pass information to the upper layers. Port numbers are used to keep track of different conversations that cross the different at the same time. Transmission Control Protocol, or TCP. TCP sets up a connection, sometimes called a virtual circuit, between end-user applications. The following are TCP characteristics. Is connection-oriented, is reliable, divides outgoing messages into segments, reassembles messages at the destination station from incoming segments, and resends anything that not received. TCP specification. TCP is made reliable with the following: sequence numbers. Each TCP packet is sent with a sequence number. Acknowledgement. Packets contain acknowledgement number. This is the sequence number of the next expected transmitted data byte in the reverse direction. On sending, a host stores the transmitted data in a storage buffer and starts a timer. If the packet is acknowledged, then this data is deleted. Else, if no acknowledgement is received before the timer runs out, the packet is retransmitted. Window. With the host sends a window value which specifies number of bytes. In this figure 7, the TCP host establish a connection-oriented session with one another using a three-way handshake. First, one host initiates a connection by sending a packet indicating its initial sequence number of X with a certain bit in the header to indicate a connection request. Second, the other host receives the packet, records the sequence number of X, replies with an acknowledgement of X plus 1, and includes its own initial sequence number of Y. The acknowledgement number of X plus 1 means that the host has received all octets up to end including X and is expecting X plus 1 next. In this figure, the figure 8, the following are the definition of the fields in the TCP segment. Source port. Number of the calling port. This identifies the upper layer process at the source end of the segment. Destination port. Number of the called port. This is the port assigned at the destination end of the segment. Sequence number. This is the sequence number for the first octet in the user data field. Acknowledgement number. The next expected TCP octet. HLEN represent bit number in the header and reserved set to 0. Control bits. Control function are such as setup and termination of a session. Window, number of octets that the device is willing to accept. Checksum, calculated checksum of the header and data fields. Urgent pointer, indicator for the end of the urgent data. Option, maximum TCP segment size. Data upper layer protocol data. User Datagram Protocol, or UDP. UDP is a simple protocol that exchanges datagrams without acknowledgement. or guaranteed delivery, error processing, and retransmission must be handled by other protocols. UDP uses no windowing or acknowledgement. Application layer protocols provide the reliability. UDP is designed for applications that do not need to put sequences of segments together. Protocols that use UDP include the following: Trivial File Transfer Protocol, or TFTP, Simple Network Management Protocol, or SNMP, Dynamic Host Console Protocol, or DHCP, Domain Name System, or DNS, and BOOTP. Lastly, the last figure, this figure 9, are the definition of the fields in the UDP header format. Source port, this identifies the local port number which should be used when the destination host requires to contact originator. Destination port, this connects to the destination. Length, this is a bytes number including the UDP header and the data. Checksum, the 16-byte 1s complement of the 1s complement sum of the UDP header and the data. Then that would be all. And thank you for watching, and good day.